Beneath the endless black, Mars turns slowly, a desert wrapped in the memory of oceans. Its surface glows faintly under the pale light of a distant sun. A world that has not known life for billions of years, yet still holds the ghost of motion in its silence. The winds sweep fine grains of iron dust across ancient dunes, whispering through craters carved before life began on Earth. There is peace in this stillness, an eternal red hush. But then, on a night that will later fracture scientific certainty itself, the silence shifts. From the void beyond Jupiter, a flicker, faint at first, then impossibly bright, cuts across the black, tracing a path no equation can predict. They will call it 3I Atlas, the third recorded visitor from another star. But on this night, it has no name, only motion, only light. Subscribe and keep watching the truth behind 3I. Atlas is still unfolding across the silent skies of Mars. Astronomers across the world strain their instruments as the signal spikes, as its velocity defies the grip of the sun. Unlike Almamua's silent slide or Borisov's icy breath, Atlas burns with a volatile emerald flare. Its reflectivity changes rhythmically, pulsing with an order that seems to breathe. Some call it rotation, others a signal. And as trajectory models converge, a single truth emerges from the chaos of numbers. It is headed toward Mars. In observatories and control rooms, the disbelief is near reverence. The odds of a true intersection between an interstellar object and a planet are infinitesimal, 1 in tens of billions. Yet, the simulations leave no doubt. The object's hyperbolic path curves unnaturally, as though guided by invisible hands. 1,000 telescopes follow it across the star fields, recording the acceleration, the oscillating emissions, the faint whisper of ionized gas around its form. It is not behaving like rock or ice, nor like anything born of our system's dust. It flickers green against the black, like a thought breaking through the void. Mars, meanwhile, remains unaware. The red planet turns, its canyons deep and cold, its atmosphere thin and trembling. But then, for the briefest instant, the horizon ignites. A flash, silent yet enormous, tears through the upper atmosphere. It is not an impact, not a collision of mass and stone, but something stranger, a resonance. The sky ripples, dust lifts, and orbiters circling above record a wave of electromagnetic interference sweeping across the planet like a heartbeat. For 20 seconds, the instruments falter. When the data returns, it bears anomalies, repeating pulses, perfectly spaced, measured in prime numbers. The scientists debate feverishly. The green flare could be spectral scattering or plasma discharge. The rhythmic interference might be coincidence or communication. But as the noise fades and the sensors quiet, Mars does not return to silence. A soft, persistent glow dances across its upper atmosphere, not red, but green. It is as though the planet itself has begun to hum, awakened from a dream it was never meant to remember. No fragments are found, no debris, no trace of collision. 3I Atlas vanishes into the black beyond the orbit of Mars, leaving only its signature, a disturbance in electromagnetic spectra, and a handful of images capturing what should have been impossible. A streak of alien light bending through the thin Martian air. Later, when the data is reanalyzed, something else emerges, a temporal distortion in the signals, as if multiple instruments recorded slightly different moments of the same event. Seconds lost, then found again, rewritten. To some, it is to others, a hint that Atlas carried not just matter, but a deeper interference, one that touched time itself. And so the question begins to echo through every laboratory, every observatory, every restless mind watching the red planet turn beneath its eternal storm. Was this a simple crossing of orbits, or a deliberate alignment? Did Mars merely pass through the shadow of an interstellar traveler, or did the traveler choose Mars? In the silence that follows, the universe seems to pause, vast, unblinking, and aware, because sometimes the cosmos does not collide by chance. Sometimes it speaks, and when it does, it leaves its message, not in words, but in the scars of worlds that once thought themselves alone. It began as a flicker, so faint it might have been nothing at all. Deep within the archives of the Pan-STARRS survey in Hawaii, a thread of motion cut against the still tapestry of stars. The algorithm caught it first, a wandering pixel shifting faster than parallax should allow. But as the Vera Rubin Observatory in Chile confirmed the same streak hours later, the numbers no longer matched any known celestial trajectory. Its acceleration was wrong, its light curve wrong, its very existence almost mathematically impossible. This was not a comet, not an asteroid, not anything born under the gravitational quiet of our sun. Its path cut through the solar system at a speed too great for capture, yet it moved as though resisting the very physics that should define it. Observers described its signature as non-gravitational, a term reserved for the rarest of anomalies. Each frame of data revealed fluctuations in brightness, rhythmic and deliberate, as though the object were turning, reflecting, pulsing in coded intervals. The light came and went like a heartbeat's timed, purposeful dot at first. They assumed rotation, perhaps a tumbling rock with a jagged face catching sunlight. But the rhythm persisted with unnatural precision, a pattern repeated over thousands of seconds, never deviating. Some scientists quietly wondered if it was an engineered symmetry, the kind seen in radio beacons or synthetic signals. Others dismissed it as coincidence. Yet, as more telescopes tracked its flight, the precision held, defying randomness. When the full orbital data was reconstructed, the astonishment deepened. Unlike Oumuamua, whose hyperbolic path had barely skimmed our system, 3I, Atlas bent around invisible contours, its arc warped, as though tugged by an unseen hand. The orbit grazed the edge of Mars' magnetosphere, a probability so small it was almost absurd. For such a trajectory to occur naturally, the universe would have to roll cosmic dice trillions of times before yielding this single throw. Then came the light. As Atlas neared Mars, spectrographs aboard Earth's largest observatories recorded emission lines unknown to chemistry. Not hydrogen, not helium, not any element in standard catalogues. The frequencies glowed in the near-ultraviolet range, accompanied by a faint band that matched neither organic molecules nor mineral plasma. The readings suggested ionization at a temperature too low for stellar radiation, yet too high for rock. Something about the object was interacting with the Martian environment, transmitting energy, altering fields, disturbing balance. Mars itself responded in kind. The thin carbon dioxide atmosphere trembled, its ionosphere shimmering like the surface of disturbed water. The MAVEN and ExoMars orbiters both detected a sharp electromagnetic pulse, a transient wave that swept from pole to pole in seconds. Communication signals momentarily wavered. Data streams glitched and returned, each now carrying microscopic distortions, faint echoes that resembled harmonics of the same pulse detected earlier. On Earth, deep space instruments captured the aftershock. Subtle, almost imperceptible variations in local gravitational readings hinted at something stranger, an energy ripple that propagated through the inner system. The instruments at LIGO and ESA's LISA Pathfinder registered anomalies on the threshold of noise, oscillations, not strong enough to be gravitational waves, yet to synchronize to be dismissed. For a moment, it was as if Mars itself had resonated, a planetary bell struck by an invisible hand. The scientific community hesitated. The numbers could be artifacts, statistical ghosts conjured by random noise. Yet, the data consistency across independent instruments gave weight to the impossible. Even the solar wind, measured by the Parker probe, showed an abrupt, unexplained fluctuation near the moment of the Atlas-Mars encounter. Something had disturbed the equilibrium of the solar system, however briefly. Weeks later, the light faded. Atlas accelerated outward, beyond the orbit of Jupiter, its glow dwindling into the void. The pulse stopped. The signals quieted, but the data millions of lines of code and spectral imprints remained. When the teams attempted to filter out the interference from Mars sensors, they discovered a pattern embedded deep within the noise, repeating intervals of prime number frequencies. Harmonically spaced, as if structured, theories began to surface, whispered at conferences and buried in research notes. Could magnetic resonance explain such precision? Could natural plasma interactions produce prime intervals? Each hypothesis strained under the weight of the evidence. The pattern, though faint, appeared deliberate, mathematical, intentional. For a time, the scientific world fell into a stunned quiet. They had seen interstellar visitors before, but none that moved like this, none that spoke in rhythm. The encounter between 3I, Atlas, and Mars was brief, mere minutes across the cosmic clock, but in its wake, a question remained, suspended between curiosity and dread. Had they just witnessed a celestial coincidence, or had something beyond the stars reached out not to Earth, but to the planet next door? Mars continued to turn beneath its thin veil of dust, silent once more. Yet the data whispered otherwise. Somewhere in that red silence, a memory of contact still hummed, faint and orderly, waiting for someone to listen closely enough to hear the pattern again. In the weeks that followed, data centers across the world began to reconstruct every available frame of the event. Teams at NASA's Jet Propulsion Laboratory, the European Space Agency, and Japan's JAXA combined telemetry from dozens of orbital instruments to create a unified timeline. What emerged was a clearer, though more unsettling, sequence. Just before the electromagnetic surge registered by the orbiters, 3I, Atlas, appeared to release a brief outflow and expanding halo of charged particles, detectable in both optical and radio wavelengths. It lasted less than 7 seconds, but traveled more than 20,000 kilometers across the Martian sky. The density and structure of the burst indicated it wasn't a random explosion of material. It appeared focused, like a controlled discharge of ionized dust. When analyzed spectroscopically, the outflow displayed anomalous absorption features, suggesting compounds not found in known meteorites or comets. Researchers compared the readings with interstellar dust samples collected by NASA's Stardust mission, but found no match. The elemental ratios, particularly of nickel to silicon, were inconsistent with ordinary cosmic dust, while trace isotopes pointed to an origin outside the galactic disk, potentially from the thick disk or even intergalactic space. The implications were significant. The object's material composition predated the formation of the solar system. Further examination of Mars' upper atmosphere revealed another anomaly. MAV's neutral gas and ion spectrometer detected a brief, measurable increase in trace organics, simple carbon-based molecules during the same interval. These compounds quickly dispersed, but their isotopic signature didn't correspond with those typically produced by photochemical reactions in Mars' thin atmosphere. They appeared foreign, introduced momentarily and then lost. Whether they originated from Atlas itself or were a byproduct of its interaction with the planet remains unknown. On Earth, ground-based telescopes continued to track Atlas as it exited the inner solar system. The object's non-gravitational acceleration persisted even after the Martian encounter. implying that the same mechanisms influencing its motion were still active. Attempts to model its trajectory using conventional physics failed to fully explain the acceleration profile. Solar radiation pressure could account for only a fraction of the deviation. Outgassing, as seen in comets, didn't fit either. There was no visible coma or tail, and the acceleration vectors did not align with the sun's direction. The remaining possibilities grew narrow and speculative. By the end of the observation period, 3-1 Atlas had crossed the orbit of Jupiter and was heading outward toward the helium. The Vera Rubin Observatory recorded its final detectable flash before it vanished beyond instrumental reach. Astronomers estimated that within a year it would be completely beyond the influence of the sun's gravity, returning to the interstellar void from which it came. But its close past by Mars left lasting consequences. A comparative analysis of the Martian magnetosphere, before and after the encounter, revealed subtle but measurable differences. The orientation of localized magnetic anomalies, particularly in the southern highlands, showed fractional deviations from baseline data collected years earlier. These shifts were small and the order of microtes less, but statistically significant. The conclusion was cautious: a temporary external field disturbance, possibly electromagnetic induction caused by Atlas plasma activity. Yet even conservative scientists admitted that such changes should not have occurred from a simple near pass. Meanwhile, an independent study conducted by ESA's Trace Gas Orbiter reported faint but persistent electromagnetic echoes in the ionosphere. The signals, repeating every 18 minutes, decayed slowly over several weeks before vanishing entirely. Whether these oscillations were residual effects or data artifacts remains unresolved. The most compelling development came from a re-examination of the data gaps recorded during the surge event. Using an eye-based interpolation, analysts reconstructed the missing sequences from multiple instruments. Within these restored fragments lay a pattern of harmonic interference, aligning closely with the original prime number frequency sequence. This finding reignited debate within the scientific community. Some proposed a natural resonance effect between Atlas' magnetic field and Mars' ionosphere. Others suggested that the frequencies represented structured emissions encoded information embedded within the electromagnetic burst. Officially, no conclusion was reached. The incident was catalogued as an anomalous interstellar encounter, pending further evidence. Yet off-record, many involved admitted the event had unsettled them. It challenged assumptions about the boundaries between natural phenomena and something more deliberate. 3-1 Atlas left no traceable debris, no impact crater, no tangible sample to study. Only data, incomplete and contradictory, scattered across instruments and archives. Mars returned to its usual calm. The solar wind resumed its steady rhythm, and the orbiters continued their long surveys. But among researchers, a quiet sense of unease persisted. They had witnessed an event that defied statistical probability and physical convention. A precise alignment between an interstellar object and a planet that hadn't hosted an atmosphere thick enough for life in billions of years. For now, the mystery remains defined by absence. No confirmation of life, no proof of intent. Only the undeniable record of interaction between two cosmic bodies, one ancient and red, the other born of another sun. In the years to come, those few minutes above Mars will continue to be studied, modeled, and debated. Whether it was coincidence or contact, 3. Atlas left behind more than questions. It left a new boundary, one that marks how little humanity truly understands about what moves between the stars. In the weeks following the Martian encounter, 3. Atlas began to fade. The once bright object that had blazed across the data streams of telescopes worldwide slipped into obscurity, its signal thinning, breaking apart, and finally dissolving into cosmic background noise. At first, astronomers assumed the dimming was natural, the fading reflection of sunlight as it moved farther from the inner system. But the rate of decline didn't match any known pattern. It didn't fade linearly or exponentially. It vanished in discrete stages, as if switching frequencies, migrating beyond the visible and into the unseen. For several nights, the Vera Rubin Observatory traced faint infrared trails in its wake, narrow, pulsing streaks that appeared and disappeared at precise intervals, and then nothing. The universe fell silent. On Mars, however, silence was not what the machines recorded. In the cold stillness of the Martian night, NASA's Perseverance rover captured something unexpected, a faint green shimmer above Gale Crater. It was not the familiar ultraviolet aurora caused by solar wind interacting with the atmosphere. This light was lower, closer to the surface, flickering with rhythmic precision, a pulse every 17.2 seconds, repeating for almost an hour before vanishing completely. The glow resembled the auroral emissions of oxygen, but its distribution defied known models. It was symmetrical, spanning the crater rim in mirrored arcs, as though following invisible field lines that no instrument could map. Teams at the Jet Propulsion Laboratory reviewed the footage, cross-referencing it with atmospheric and magnetic data. The readings aligned perfectly with the predicted time when Atlas' electromagnetic surge would have reached the planet's ionosphere. Yet there was no direct trigger, no solar flare or cosmic ray burst. Some researchers speculated it might have been residual energy from the object's passage, trapped temporarily in Mars-weak magnetic anomalies, re-emitted as light when the atmosphere cooled. Others were less certain. The glow's rhythmic nature hinted at an external modulation, as if responding to a signal that no receiver was built to hear. But what unsettled mission controllers most wasn't the light itself, it was time. In the hours following the event, time-stamped data from orbiters and surface probes refused to align. The Mars Reconnaissance Orbiter reported its internal chronometer lagging by almost 47 seconds compared to the ExoMars Trace Gas Orbiter, an impossible drift for synchronized atomic clocks. Even the data relayed through the Deep Space Network showed inconsistencies, as though the electromagnetic burst had bent the flow of recorded time. When engineers recalibrated the clocks, the offsets vanished, but the raw data remained permanently out of phase. For scientists trained to treat time as the most reliable constant, this was an intrusion of chaos. Then came the images. As the Martian dust storms intensified in the following weeks, Mr. O's spectrometer picked up subtle, repeating geometric imprints in the airborne debris, triangular formations, grid-like alignments, at first dismissed as processing artifacts. Yet the patterns persisted across multiple instruments and imaging passes, each separated by hundreds of kilometers and hours of orbital drift. The grids rotated, shifted, and realigned, forming sequences that, when mapped, resembled mathematical tessellations. No natural atmospheric process could account for the precision. Some analysts proposed interference from the onboard imaging systems, a kind of electromagnetic echo bleeding through sensor layers. Others quietly wondered if the dust itself had been magnetized, momentarily organized by forces that had brushed the planet weeks earlier. During this period, deep space communications began to fracture. Signals to several arbiters collapsed intermittently, replaced by structured, static, not random noise, but narrowband pulses with measurable symmetry. When decoded through standard error correction algorithms, they produced repeating prime number intervals, similar to the harmonic distortions recorded during Atlas initial detection months prior. Engineers tried to isolate the source, but every attempt ended in the same conclusion. The interference did not originate from Mars, Earth, or the relay satellites in between. It existed somewhere in the space between them, a transient field, appearing and vanishing without physical origin. The mystery deepened not only through what was observed, but through what was no longer trusted. When the act of observation itself began to distort, when time drifted, when geometry replicated, when signals mirrored their own structure, the scientific method faltered. The data remained precise, but the meaning behind it unraveled. A growing number of physicists began to question whether Atlas' influence was limited to electromagnetic or gravitational effects, or if something deeper had been disturbed, the fabric of measurement itself. In academic circles, a new term emerged: observer interference threshold, the hypothetical point at which the universe begins to respond to its own observation. Quantum mechanics had long suggested that measurement could influence behavior at the smallest scales, but never had such an idea been considered in celestial terms. What if the passage of 3I Atlas had been not merely physical, but informational, an event that changed the conditions of perception, forcing the cosmos to momentarily recognize its own reflection? Mars, silent and ancient, became the mirror. Its red dust, stirred and shaped into geometry, seemed to echo the same mathematics written in the interference of radio waves and the flicker of dying light. Across millions of kilometers, human technology strained to interpret, to categorize, to explain, but the instruments that once defined certainty now hinted at a deeper ambiguity, a universe that didn't simply allow observation, but occasionally responded to it. In that quiet uncertainty, one truth remained constant: 3I Atlas had not simply passed through the solar system, it had left behind a disturbance in the very framework of understanding, a reminder that perhaps the cosmos is not a silent stage, but an active participant. And somewhere, beyond the reach of telescopes, beyond the fading infrared trail, something continued to move, unseen, but not entirely gone. Over the following months, the global scientific community mobilized in an attempt to stabilize the mystery surrounding 3I Atlas. Observatories across the world recalibrated their sensors, seeking any remaining trace of the object or its electromagnetic residue. The results were inconsistent. In some regions, faint residual spikes appeared across multiple spectrums: infrared, microwave, even low-frequency radio, but none followed predictable decay curves. Some intensified unexpectedly, as if amplified by the act of measurement itself. Others vanished mid-observation. The irregularity made modeling impossible. Teams at NASA, ESA, and the Square Kilometre Array in South Africa coordinated continuous tracking cycles, each feeding data to central AI-driven analytic clusters. Yet every attempt to find a coherent signal ended in the same unresolved conclusion: 3I Atlas was no longer detectable, but its influence persisted in the instruments that had once observed it. On Mars, the anomalies grew more complex. The light emissions first seen over Gale Crater became sporadic, now appearing across new latitudes, faint glows recorded by Perseverance, Curiosity, and even the Chinese Zhurong rover before its hibernation. These emissions occurred during local dusk, when solar activity was at a minimum. Their wavelengths did not correspond to auroras or dust interactions. Some researchers suggested piezoelectric effects, caused by friction between silicate particles in the dry atmosphere, but no mechanical process could explain the consistent spectral pattern or its repetition interval. The readings hinted at a structured energy release, not random activity. The European Space Agency's Mars Express began cross-referencing atmospheric data with orbital magnetometer readings. It found faint, localized fluctuations in the planet's residual magnetic field, regions that appeared to oscillate between measurable states. These were not magnetic storms or plasma waves. They were isolated pockets of field inversion, lasting only seconds before dissipating. Though minor in strength, their timing aligned with the brief optical emissions seen from orbit. It was as if something had embedded a recurring signal within the planet's upper atmosphere, too weak to be noticed until instruments became sensitive enough to detect it. Meanwhile, the issue of time discrepancies continued to create confusion among mission engineers. The atomic clocks on board orbiters had been synchronized post-event, but inconsistencies persisted in raw data transmission delays. Signals sent from Mars arrived a fraction of a second earlier than predicted by standard light time calculations. The differences were minuscule, microseconds, but statistically significant when averaged across thousands of transmissions. This deviation raised difficult questions. Either the Deep Space Network was miscalculating travel times due to undetected solar interference, or space-time geometry between Earth and Mars had been subtly altered. The latter was dismissed publicly but discussed quietly within closed research groups, especially among teams working on gravitational field analysis. In parallel, ground-based detectors on Earth picked up a series of low-level gravitational wave fluctuations unrelated to known cosmic events like neutron star mergers or black hole collisions. The Laser Interferometer Gravitational Wave Observatory LIGO classified them as sub-threshold noise, but several patterns mirrored the earlier electromagnetic pulse signature. Recorded from Mars, analysts debated whether the correlation was coincidence or evidence of a connected resonance, a possibility that, if true, would imply that 3-1 Atlas had generated a short-lived distortion, extending beyond planetary scales. A consortium of astrophysicists proposed that the object's anomalous acceleration prior to disappearance might have been caused by a process unknown in conventional mechanics, possibly an interaction between interstellar plasma and a self-contained magnetic envelope. If 3I Atlas possessed an internal energy source capable of modulating electromagnetic fields, it could theoretically manipulate its own trajectory in response to gravitational gradients. This hypothesis, while speculative, aligned with earlier observations of non-gravitational motion in similar interstellar visitors like Alma, but where Alma's acceleration could be modeled through radiation pressure. 3I Atlas exhibited vector shifts inconsistent with that mechanism. It seemed to alter velocity along axes unrelated to solar influence, as if responding to a different point of reference entirely. As data accumulated, models diverged. Some researchers argued that the anomalies on Mars were secondary, byproducts of high-energy interaction between the object's field and the planet's ionosphere. Others proposed that Mars had absorbed a portion of the energy, retaining it in its crust or atmosphere as long-term electrical potential. If so, the faint lights and magnetic pulses might represent gradual discharge, but a minority suggested a more fundamental explanation, that 3I Atlas had triggered an informational imprint, a restructuring of local electromagnetic equilibrium. Not unlike the way quantum systems retain coherence even after observation ends. In this view, Mars was not reacting but remembering. The growing divide between conventional and speculative interpretations reflected a deeper tension, one between measurement and meaning. Every new dataset expanded understanding, yet undermined the stability of previous conclusions. 3-1 Atlas had arrived, interacted, and departed, but in doing so, it had introduced measurable effects that did not fit within known parameters of celestial mechanics or planetary physics. The object's absence became as significant as its presence, its legacy defined not by what it was, but by what it had changed in the systems left behind by the end of that cycle. The consensus among researchers was pragmatic. Continued observation was necessary, even if comprehension remained distant. Mars, once considered static and predictable, had become a testing ground for phenomena beyond the reach of current science. The instruments would continue their vigil, tracking, recording, waiting, in the hope that somewhere, in the silent data streams, the mystery of 3I Atlas would reveal itself once more when astronomers began retracing the fading trajectory of 3I Atlas. They found themselves staring into a patch of sky that was, by all conventional maps, empty. The object's path, once plotted backward through time and space, did not originate from any familiar stellar nursery or known system. It came from the region between Lyra and Hercules, a dark corridor of interstellar space devoid of major stars, gas clouds, or nebula structures. Nothing in that direction produced enough light or energy to explain an ejection event. The void from which it emerged offered no clear origin, as though 3I Atlas had not come from anywhere, but rather appeared into existence along its inbound arc. The first alerts went largely unnoticed. The Pan-STARRS network in Hawaii detected an object moving irregularly across successive night frames, its light curve fluctuating too sharply to be a standard comet or asteroid. Minutes later, a similar signal appeared in data from China's Purple Mountain Observatory, and then from the European Space Agency's Gaia tracking logs. Within hours, 3 continents were observing the same moving anomaly. But the early consensus leaned toward a data glitch, perhaps a cosmic ray strike or a calibration fault. Only when independent verification arrived from the NASA Jet Propulsion Laboratory did the tone shift. The object was real, and it was fast, faster than any previously recorded interstellar body. Triangulation began immediately. The Global Deep Space Network, a constellation of radio telescopes stretching from Canberra to Madrid to Goldstone, synchronized to capture every passing reflection and pulse. The object exhibited faint microwave emissions, possibly thermal radiation from surface charging, but the signal intensity varied rhythmically, like a beacon. That modulation was what first set 3I Atlas apart from its predecessors. Almumor had glided silently, accelerating in ways that challenged physics but offered no emission pattern. Borisov had burned bright and familiar, its cometary tail following predictable chemistry. 3I Atlas did neither. It flickered, not randomly, but with deliberate structure, as though something within it was oscillating, comparing the trajectories of these 3 interstellar visitors revealed a trend that made the scientific community uneasy. The frequency of such arrivals appeared to be increasing. For centuries, the solar system had existed in relative isolation, unvisited by objects born beyond its gravitational reach. Yet in a single human generation, 3 had appeared, each more anomalous than the last. Models that once treated interstellar objects as statistical rarities had to be rewritten. Some suggested that the solar system was entering a denser region of the galactic medium, a corridor of wandering debris expelled from long-dead stars. Others speculated that these weren't random visitors at all, but remnants of an ancient galactic migration, ejected from systems older and more unstable than our own. The turning point came with the Atlas Array, a new generation of deep-field radar systems spread across mountain observatories and orbiting platforms. Designed to detect near-Earth asteroids and planetary hazards, these systems had been calibrated for predictable motion. 3I Atlas nearly escaped their notice entirely. Its erratic, pulse-like velocity caused most detection algorithms to reject it as noise. Only when a junior astronomer at the Rubin Observatory, cross-referencing archived telemetry, noticed recurring intervals in its infrared returns, did the system flag it as a valid body. That moment, an overlooked line of code, a recalculated anomaly, became the genesis of one of the most significant astronomical events in modern history. For the scientists involved, discovery came not with triumph, but disbelief. Reports from the initial observing teams reveal hesitation to publish. The brightness curve fluctuated too precisely, the motion too irregular. At first, they assumed an artificial satellite glitch or a distant fragment of spacecraft debris reflecting sunlight. But orbital dynamics disproved every simple explanation. Within 48 hours, confirmation came from radar imaging. 3I Atlas was large, irregular, and accelerating through the solar system on a hyperbolic trajectory. Its vector placed it dangerously close to the orbital path of Mars. Behind the data, however, were the people, the reluctant discoverers, who watched their instruments defy their own understanding. Some worked overnight in dimly lit control rooms, recalculating orbital solutions again and again, each time returning to the same impossible result. Others debated whether the anomaly should even be announced, fearing public misinterpretation after the controversies surrounding Oumuamua's debated origin. When the official statement was released, it was stripped of speculation. The language was cautious, almost sterile, an interstellar object of non-gravitational acceleration. Designation 3I Atlas has entered the inner solar system, but within research circles, unease grew. Its speed, composition, and trajectory defied probability. To such a degree that chance alone seemed insufficient as an explanation. As its path was traced closer toward Mars, the conversation shifted from curiosity to caution. Simulation models projected a near approach with low likelihood of collision, but even a remote encounter with such an object held unpredictable consequences. Researchers revisited older datasets, searching for signs that Mars might have been visited before. There were subtle geological patterns, certain isotopic anomalies in meteorites, unexplained magnetic reversals in the Martian crust that suddenly seemed newly relevant. Some began to wonder if the meeting between Mars and 3I Atlas was not random at all. Mars, once home to flowing water, a thicker atmosphere, and perhaps microbial life, stood as the solar system's silent relic of lost potential. It was the planet most like Earth, and yet eternally lifeless. In speculative circles, a question emerged. Could interstellar objects like Atlas serve as carriers, not of life, but of information, fragments of cosmic history scattered across the galaxy? If so, Mars' encounter with one might not be an accident, but a continuation of something that began long before human observation, an exchange written into the structure of space itself. And so, even as the data poured in, the deeper story began to form, not just of what was seen, but of what it suggested. The more astronomers looked backward, tracing the object's path through an empty quadrant of space, the more it seemed that 3I Atlas carried with it a kind of silence, the silence of origins that could not be traced, and of connections that might reach beyond what any telescope could yet resolve. As the months progressed, the scientific focus shifted from immediate tracking to deeper analysis of 3I Atlas's recorded data. High-resolution observations from the Deep Space Network were reprocessed using machine learning algorithms designed to filter out noise from weak interstellar signals. The recalibrated datasets revealed previously undetected spectral line-narrow emissions, clustered around unusual frequencies near 3.1. These emissions did not correspond to any known chemical signatures or plasma states observed in natural interstellar bodies. The readings were too clean, too sharply defined to result from random scattering. In scientific terms, this was described as coherent emission but the underlying cause remained unknown. Parallel to these efforts, Mars continued to be monitored as a potential secondary data source. Its orbiters provided indirect confirmation that the electromagnetic conditions near the planet had altered subtly since the close passage. Small but measurable variations appeared in the ionospheric density and radio propagation delay. None were catastrophic or visually dramatic, but they were persistent, consistent with a long-term residual field effect. Engineers recalculated instrument calibrations several times, but the deviations remained constant, leading to the hypothesis that the Martian atmosphere had absorbed and retained a portion of 3I Atlas's passing energy dot by the end of the observation cycle. International agencies classified 3I Atlas as an interstellar object of anomalous physical properties, a designation distinct from standard cometary or asteroidal types. The data suggested a phenomenon that operated outside typical gravitational and thermodynamic parameters. While the object had long since vanished from visual range, its trajectory, emissions, and aftermath on Mars remained active fields of study. The conclusions reached were cautious but clear. 3I Atlas represented a category of interstellar visitor for which no precedent existed. Its origins, material composition, and behavior defied standard astrophysical explanation. The scientific record would preserve it as a data, anomaly, and a challenger, reminder that even in an era of advanced observation, the universe retains the capacity to produce events that resist complete understanding. The trail of 3I Atlas, traced from an empty region of space to the red deserts of Mars, stood as evidence of that enduring uncertainty. In the months that followed, the scientific world began to fracture along invisible lines. What began as a collective pursuit of understanding soon transformed into a quiet, Sisyphon echo of every great scientific divide that had come before. On one side stood those who saw 3I Atlas as a coincidence of physics, a natural interstellar body governed by forces yet to be fully mapped but ultimately explainable. On the other were those who whispered that its behavior, its coherence, its interaction with Mars hinted at something more deliberate. The debate unfolded not in conference halls, but in encrypted emails, late-night video calls, and private symposiums, where reputations and reason balanced on the same fragile scale. Comparisons emerged to older struggles, the heliocentric revolt of Galileo, the century-long search for radio signals by SETI, the deep cosmic silence that followed. Each era, it seemed, reached a point where science confronted the boundary of its own certainty. 3I Atlas had become this generation's frontier, a mirror reflecting both human brilliance and human doubt. Observatories released cautious statements, thick with neutral language, yet between the lines lingered unease. Something about this object defied the comfort of probability. Something about it refused to remain silent. Ethical questions soon followed. If Mars had been changed, if its fragile atmospheric balance had been even slightly disturbed, did humanity now bear a responsibility to intervene? Was observation still neutral when it came with knowledge of consequence? The debate drew parallels to planetary protection protocols established during the Viking and Perseverance missions, the moral imperative to prevent contamination of other worlds. Yet 3I Atlas blurred those lines. This was not a contamination introduced by humanity, but by the universe itself. Could human hands repair what interstellar forces had touched? Should they even try? Committees formed under NASA, ESA, and the UN's Office for Outer Space Affairs. Their discussions were sober, filled with concern over jurisdiction, responsibility, and perception. Some advocated for a new generation of sterilized probes to survey the Martian upper atmosphere. to determine what, if anything, had changed. Others warned that any further interference risked compounding an unknown variable. Quietly, the consensus leaned toward inaction. Humanity would watch, measure, and wait. It was the only decision that did not feel like intrusion. But outside the institution's restraint was rare. Media networks seized the story, weaving a spectacle of speculation. Headlines spoke in absolutes. Alien beacon over Mars, the visitor that woke the red planet, proof of extraterrestrial design. Satellite images, some genuine, others digitally enhanced, flooded social channels. A pattern of bright points near the Martian equator was presented as evidence of a coded transmission. In truth, the points were standard data compression artifacts. Yet once released, the myth became self-sustaining. Ratings soared. Fear spread faster than facts. Inside research facilities, the atmosphere grew tense. Some scientists were placed under communication restrictions. Portions of the raw telemetry data, particularly those capturing electromagnetic surges during 3I atlases, closest approach, were reclassified by defense agencies under joint security agreements. Publicly, the justification was to prevent misinterpretation or exploitation of sensitive sensor technologies. Privately, it deepened suspicion. Whisper networks formed among researchers, trading fragments of information, missing data packets, unexplained gaps in observation logs, strange similarities in frequency modulations. The missing details became more provocative than any confirmed fact. The psychological strain was immense. Analysts who had spent years studying predictable orbital mechanics now found themselves staring into uncertainty. Sleep became elusive. Reports circulated of researchers experiencing disorientation and déjà vu during simulation analysis moments, where datasets seemed to repeat themselves, as though echoing patterns from earlier computations. Some dismissed it as fatigue, others as software feedback errors. Yet for a few, the sensation carried something deeper, like the data itself was aware of being watched. Religious and philosophical voices soon joined the global conversation. Theologians spoke of cosmic purpose, others of existential humility. What if 3I Atlas was not simply an interstellar rock, but a messenger, a fragment of something ancient, crossing the void, not by chance, but by design? The speculation found resonance not in evidence, but in emotion. For a civilization accustomed to isolation in the cosmic dark, the idea of being noticed carried both wonder and dread. Was this discovery an invitation or a warning? Scientists, burdened with the weight of objectivity, watched as the narrative spiraled beyond their control. Their data, precise, technical, often incomplete, was now interpreted through every human lens of belief and fear. Funding increased, oversight expanded, and privacy vanished. In the effort to study 3I Atlas, the world had inadvertently turned itself into an experimental study in how knowledge, once unbound, transforms those who seek it. The object itself was gone, fading into the distant black beyond Neptune's reach. Yet its presence lingered, imprinted not in orbit or atmosphere, but in human consciousness. It had divided scholars, shaken faith, and rewritten policy. It had exposed a truth older than science itself, that discovery is not a single act of seeing, but a collision between knowledge and meaning. And in that collision, humanity was once again reminded how thin the line is between enlightenment and fear. As the dust of controversy settled, a quieter phase began, an era defined not by excitement but by introspection. Committees that once convened daily now met in subdued intervals, their discussions steeped in cautious pragmatism. The data surrounding 3I Atlas was still under review, scattered across secured databases in Houston, Beijing, Darmstadt, and Canberra. The goal had shifted from understanding the object itself to understanding the implications of its passage, what its existence revealed about interstellar traffic and planetary vulnerability in this new atmosphere. Global research networks restructured their efforts. The International Astronomical Union began mapping all known transient interstellar objects with renewed precision, while the European Space Agency funded algorithms designed to detect subtle accelerations in moving bodies, an attempt to catch anomalies before they vanished again. Yet, no matter how much technology advanced, the question that haunted scientists remained untouched. Was 3I Atlas entirely natural, or had something within its structure behaved with intention? Theories continued to emerge. Some proposed that its strange motion could be explained by outgassing jets similar to what was once speculated for Alma-Mu'a, but on a far more controlled scale, producing thrust without visible debris. Others suggested electromagnetic propulsion caused by superconductive mineral veins reacting to solar radiation. Both hypotheses were internally consistent but left gaps. The observed rhythmic light fluctuations, the near-symmetrical energy bursts detected around Mars, and the pattern in the telemetry, none of these fit comfortably within known natural mechanics. Meanwhile, the classified sections of the dataset became a quiet battleground between transparency and national interest. Agencies cited concerns about premature conclusions and potential technological implications. Independent scientists protested through open letters and journal editorials, demanding the release of all data related to the Martian electromagnetic surge. The debate reflected a long-standing tension in space researcher, fine balance between open science and security. In this case, secrecy only deepened the sense that something larger was being withheld. Yet the most troubling discoveries were not in the classified files, but in the confirmed ones. Follow-up scans of Mars revealed residual disturbances in its magnetosphere, subtle yet measurable. The planet's ionospheric density fluctuated in cycles that corresponded loosely to the object's departure timeline. These were not dramatic changes, more akin to faint echoes than direct consequences. But they persisted longer than any transient solar event should. Even with updated models, scientists could not fully explain the lingering electromagnetic imbalance across the field. The tone of the discussion began to change. No longer did researchers argue about whether 3I Atlas was intelligent or artificial. Instead, they began examining what its brief passage revealed about the solar system itself. The encounter forced a re-evaluation of how cosmic materials interacted with planetary magnetic fields, and how fragile those fields truly were. Some astrophysicists speculated that objects like 3I Atlas might be far more common than observed, their interactions leaving faint fingerprints distortions in data that humanity had simply overlooked for decades. In the background, technological arms of the space industry capitalized on the fascination. New sensors were proposed for the upcoming generation of arbiters, designed to detect high-frequency plasma interference and spectral anomalies. The private sector, driven by public curiosity, announced the Atlas Initiative, a coalition of observatories aimed at real-time tracking of deep space visitors. Behind the polished statements of collaboration lay a shared motive: preparedness. If something like 3I Atlas appeared again, no one wanted to be caught off guard. Public interest, though quieter than during the initial frenzy, had not disappeared. Online communities continued dissecting every released paper, every updated dataset. Forums debated orbital mechanics with the same fervor once reserved for geopolitics. For the first time in generations, astronomy was no longer an abstract science, it was a field directly tied to existential curiosity. People wanted to know not just how the universe worked, But whether it was aware of its observers, philosophers, and psychologists found themselves drawn into the discussion once more. They noted how the human response to 3I Atlas revealed a collective pattern: fear at first, followed by fascination, and finally acceptance. This emotional progression, they argued, mirrored humanity's long relationship with the unknown. Every discovery that pushed the boundaries of understanding, whether the heliocentric model or quantum mechanics, had followed the same arc. In this sense, 3I Atlas was not just a celestial anomaly, but a psychological mirror reflecting the way civilization confronts uncertainty. By the time a year had passed, Mars appeared unchanged. Its skies still carried thin clouds of iron dust. Its surface remained silent, marked only by wind and time. Yet among those who studied the event, a quiet conviction had taken root. Something in the solar system's story had shifted. The passage of 3I Atlas was not just an encounter, was a signal, not in the form of a message, but as a reminder that even in the well-mapped expanse of near space, there are forces, and designs that remain beyond human grasp. And as new telescopes turned their gaze toward the constellations of Lyra and Hercules, the suspected origin of the object, there was an unspoken awareness that the next discovery might not merely pass by. It might arrive with purpose in the months that followed the encounter. The search for answers turned inward into the servers of observatories, the memory cores of satellites, and the magnetic strata of Mars itself. The event that once seemed like a transient spectacle had left behind a network of invisible imprints. Teams from NASA's Jet Propulsion Laboratory, ESA's Space Operations Center, and the Chinese National Space Science Center began the process of digital reconstruction. They fed the data from every instrument, optical, infrared, and radio, into supercomputers capable of simulating planetary-scale electromagnetic interactions. The models ran for weeks, rendering millions of variables from atmospheric density to interplanetary plasma flow. Yet, with each iteration, the same conclusion emerged. No simulation could reproduce the electromagnetic patterns detected during 3I Atlas's passage. Whatever occurred near Mars did not fit within the known boundaries of physics as currently understood. Attention then shifted from the sky to the planet. The Martian crust, already known for its ancient magnetic anomalies, offered subtle new clues. Higher resolution scans revealed microscale reorientations in the magnetic alignment of surface rock tracers, suggesting that a transient yet powerful magnetic disturbance had swept across the landscape. These findings were small in magnitude but consistent in pattern, concentrated across a broad elliptical region on the northern plains. The anomaly did not correspond to any known geological or atmospheric event. In thermal imagery, this region appeared as a faint halo slightly warmer than its surroundings, as though the regolith had been briefly charged and released. The scientists called it the ghost scar, a silent residue of interaction without impact. As teams continued to analyze the event window, they revisited the brief blackout in orbital communications, the hours when several Mars orbiters had fallen into signal interference. Within the static of recovered telemetry, a peculiar sequence was uncovered, a pattern of pulses spaced according to prime numbers. It repeated precisely 5 times before vanishing. Mathematically, it could have been noise shaped by coincidence, a byproduct of overlapping frequencies. Yet to others, it appeared intentional structure, too deliberate to ignore. In science, prime numbers have long been associated with the concept of artificial signaling, for they are fundamental, universal, and unambiguous. The discovery reignited old debates about interpretation versus imagination. The green light phenomenon, officially designated the Atlas aurora, remained equally elusive. Analysis of its spectral signature revealed wavelengths not typical of solar particle interactions. Unlike polar auroras triggered by solar wind, this display originated from the mid-latitudes, where magnetic field strength is weaker. Moreover, its luminosity decayed in a logarithmic pattern, more akin to a controlled discharge than a natural atmospheric glow. Some proposed it was a photochemical reaction triggered by ionized dust and trace gases excited by a passing magnetic field. Others suggested it might have been an after effect of electromagnetic resonance Mars briefly responding to a frequency imposed from beyond when Earth's telescopes turned back toward the trajectory of 3I Atlas. They found only emptiness. The object had vanished from all known coordinates. Yet, the background data, the faint hum of the cosmic microwave radiation, showed something extraordinary, a localized distortion, a gentle curvature in the afterglow of the early universe itself. Though small, it was statistically significant. Cosmologists debated whether it represented gravitational lensing from an unseen mass, or something stranger ripple left by an object that momentarily bent the very fabric of space it crossed through. The concept was difficult to verify, but it aligned with previous observations. 3. I-Atlas did not behave like a passive rock moving through gravity. It interacted, it altered, it left marks not of collision, but of contact. In closed meetings, scientific councils began compiling a unified chronology of the event. Every sensor anomaly, every spectral irregularity, every timing discrepancy was catalogued. The timeline showed an eerie coherence, a synchronized series of disturbances, spreading outward from the moment 3I Atlas crossed Mars's orbital path. It was as though the planet and the object had briefly shared a resonance and exchange measured, not in visible light, but in rhythm. Speculation deepened. Some theorized that 3I Atlas carried a magnetic field generated internally, possibly by motion within a superconductive core. Others proposed that it was hollow, containing materials capable of producing electromagnetic feedback loops under solar exposure. More conservative voices suggested the apparent synchronization was an observational illusion, an alignment of random fluctuations amplified by expectation. Yet none could fully dismiss the mathematical precision underlying the prime number signal, or the sustained energy imbalance that lingered in Mars's atmosphere for days afterward. By now, the mystery had evolved from a question of what 3I Atlas was to what it represented. Its behavior blurred the distinction between natural and constructed, between physics and intention. Scientists who once dismissed the idea of interstellar intelligence found themselves re-examining the data, not as believers, but as cautious empiricists acknowledging the possibility of unknown mechanisms. The encounter had forced a confrontation with the limitations of current models. As the investigations continued, one truth became clear. Mars had been changed, not in form, but in signature. Its magnetic lines carried a subtle irregularity. Its thin skies retained a whisper of imbalance. And somewhere between Lyra and Hercules, in a space beyond the reach of the most powerful telescopes, a silence persisted. Whether that silence marked absence or purpose remained beyond knowing. Yet to those who studied the faint traces left behind, the message was unmistakable. The universe had spoken not in words, but in patterns, in pulses, in the quiet distortion of the cosmos itself. As the data accumulated, the focus shifted toward verification. Scientific institutions across multiple nations cross-referenced results, searching for consistency across independent instruments. The goal was simple: determine whether the anomalies were real physical events or artifacts of measurement. The European Space Agency's ExoMars Trace Gas Orbiter, the Indian Mars Orbiter mission, and NASA's MAVEN probe all reported irregularities in the electromagnetic spectrum within the same narrow time frame. Although each used different equipment, their data shared an identical time offset milliseconds apart, yet perfectly synchronized relative to the object's closest approach to Mars. This cross-correlation effectively eliminated the possibility of instrumentation error. Something external had affected all sensors. Simultaneously, the prime number sequence extracted from the recovered transmissions became the most controversial element. Cryptographers, physicists, and data analysts examined the waveform for compression signatures or digital interference patterns. None were found. The data bore the characteristics of a naturally modulated analog signal, yet the pulse intervals maintained mathematical uniformity. Independent analysis at MIT's Kavli Institute confirmed that the probability of such a pattern forming by chance was below 1 in 10 million. Even so, the scientific community hesitated to label it intentional. The lack of repetition beyond the 5 sequences made it impossible to establish structure or syntax. The consensus formed around a cautious classification, anomalous non-random emission. Meanwhile, geological assessments from orbiters revealed something unexpected beneath the ghost scar region. Subsurface radar detected a layer of increased electrical conductivity approximately 10 meters below the regolith. Normally, this would suggest saline deposits or metallic mineral content, yet spectroscopy indicated neither. Instead, the layer exhibited dielectric properties similar to vitrified material rock, partially transformed by heat or electromagnetic discharge. The geometry of this layer roughly matched the distribution of magnetic anomalies above it, forming a faint ellipse spanning nearly 50 kilometers. It was as though a transient field had brushed across the planet's crust, aligning minerals and altering their conductive states, without leaving a physical crater. Efforts to simulate such an effect encountered fundamental limits. Conventional electromagnetic models could not account for the uniformity of the transformation. To create an energy field of that precision would require a source capable of generating a coherent waveform over an enormous area, something beyond known planetary scale processes. The alternative explanations, atmospheric plasma interaction or induced magnetospheric resonance, could reproduce some features, but not all. Researchers at Los Alamos proposed a novel interpretation, a self-stabilizing plasma sheath generated by a rapidly rotating superconductive object. If 3I Atlas contained internal layers of conductive materials exposed to interstellar magnetic fields, it could, in theory, generate complex electromagnetic behavior as it moved through solar wind. The hypothesis remained speculative, but it aligned with a few observed parameters, particularly the fluctuating brightness and non-gravitational acceleration detected. During its approach, attention returned briefly to the distortion in the cosmic microwave background. Follow-up observations from the Atacama Cosmology Telescope and the South Pole Telescope found weak confirmation of the anomaly area slightly cooler than its surroundings, consistent with gravitational lensing. However, there was no corresponding visible or infrared object to cause it. The lensing mass, if it existed, would have to be either extremely compact or composed of non-luminous matter. This led to further speculation. Could 3I Atlas have been accompanied by an unseen component, perhaps an envelope of dark matter or an exotic plasma field interacting with normal space in unpredictable ways? While debate continued, planetary scientists noted a smaller but measurable effect on Mars itself. Mavner's magnetometer recorded subtle fluctuations in the planet's induced magnetic field for several weeks after the encounter. The variations decreased gradually but did not return precisely to baseline. The difference was marginal, less than 1%, but statistically persistent. It suggested a long-term alteration in the way the solar wind interacted with the Martian atmosphere. In essence, Mars's electromagnetic environment had been slightly retuned. These cumulative findings transformed the 3I Atlas event from a transient astronomical curiosity into a case study in cross-disciplinary investigation. Astronomers, physicists, and planetary geologists collaborated to map every consequence of the encounter, treating it as a controlled experiment written by nature itself. Even without direct observation of the object, its influence could be reconstructed through secondary evidence-distorted fields, altered minerals, synchronized anomalies. Step by step, a pattern emerged. 3I Atlas was not simply passing through, it was interacting with everything it approached. Despite all this progress, a core uncertainty remained. No known trajectory could fully explain its disappearance. Gravitational mechanics dictated that an object on a hyperbolic orbit should remain observable until it exits the solar system. Yet 3I Atlas had vanished sooner than models predicted, without any trace of residual light. The simplest explanation was a sudden change in albedo or orientation, but radar follow-ups detected no reflection at all. A minority of researchers began to entertain a less conventional hypothesis that the object had transitioned into a non-reflective state, perhaps enveloped in plasma dense enough to obscure it from visible detection. The final reports from this phase of investigation concluded with restraint. There was no definitive proof of intelligence, no conclusive evidence of artificial design, but neither could the data be fully explained by standard celestial dynamics. For now, 3I Atlas remained a statistical outlier, a physical anomaly without precedent. Its passage left Mars altered in measurable ways and humanity altered in perspective. The event had expanded the boundary of what could be observed, yet it had also exposed the limits of what could be understood. At the threshold where data ends and speculation begins, science stands on uncertain ground. The 3I Atlas event forced that boundary wider than ever before. For years, astronomers had understood interstellar objects as passive wanderers, frozen relics drifting between stars, propelled only by the quiet arithmetic of gravity. But 3I Atlas behaved differently. Its path could not be solved by celestial mechanics alone. Its acceleration, though faint, persisted long after it should have stabilized, and its luminous output pulsed in unnatural synchrony. The evidence suggested not random tumbling, but a form of controlled motion, an object responding to forces beyond the standard gravitational field. The first major hypothesis came from astrophysicists at the Max Planck Institute: non-gravitational propulsion through radiation pressure. The idea was that sunlight itself, reflecting off an unusually high albedo surface, could push the object like a sail. It was the same concept once proposed to explain Oumuamua's anomalous motion, but in this case the magnitude was stronger. To achieve such propulsion, 3I Atlas would need a surface structure only millimeters thick, extending across kilometers, slight enough to be moved by photons, yet rigid enough to survive interstellar travel. If true, it would imply a physical engineering precision unmatched by natural formation. Others advanced a different possibility: plasma propulsion. Observations of variable ion emissions along its trajectory hinted at outgassing or electromagnetic discharge, yet the spectral data did not match conventional volatile compounds. Instead, there were traces of ionized metals, magnesium, titanium, and nickel in ratios not consistent with simple sublimation. Some researchers speculated that 3I Atlas might generate thrust through interaction with the solar wind itself, converting magnetic energy into momentum, much like a natural magnetic sail. Whether this was a self-regulating mechanism or the byproduct of an exotic composition remained unresolved. In the wake of these theories came the quantum dust hypothesis. A team from Kyoto University suggested that the object's composition might include minerals capable of quantum coherent structures that could momentarily align with planetary magnetic fields at a quantum level. If so, its passage near Mars could have induced temporary magnetic synchronization, explaining both the aurora-like glow and the faint rhythmic pulses recorded during the encounter. While the notion bordered on speculative physics, it was grounded in real experiments. Certain crystalline materials on Earth can exhibit quantum entanglement effects under extreme magnetic stress. 3I Atlas, passing through diverse stellar environments, might have carried such materials naturally evolved under unknown cosmic conditions. Then came an observation that pushed the event from the strange to the nearly impossible. On the same day the electromagnetic surge reached Mars, Earth-based detectors, specifically 2 interferometers designed for gravitational wave detection, registered a faint, localized distortion. It was not strong enough to be classified as a true gravitational wave, yet it mirrored the timing of the Martian anomaly almost precisely. The signal, cross-referenced between LIGO and Virgo observatories, displayed a symmetrical pattern, as though space-time itself had briefly oscillated in resonance with the object's movement. Most physicists dismissed it as coincidental noise, but the alignment remained statistically suspicious. If connected, it would mean that 3I Atlas had generated a measurable gravitational echoan effect far beyond any natural mechanism, yet observed in such a small mass. Parallel to these physical mysteries, something subtler unfolded in Mars's upper atmosphere. Spectrometers detected trace signatures of complex carbon chains molecules resembling amino acid precursors. Normally, these would be attributed to meteoritic input or organic contamination, but the timing was problematic. The concentration spike appeared within 48 hours of the Atlas encounter and declined rapidly afterward. These were not simple hydrocarbons, but structured organics, polycyclic, aromatic compounds, consistent with those found in carbonaceous chondrites materials known to be precursors to prebiotic chemistry. Some planetary scientists proposed that the interaction with 3I Atlas might have dislodged dormant organic compounds from the Martian regolith, releasing them into the atmosphere. Others entertained a far more provocative idea that Mars had been seeded with new material, microscopic particles carried within the object's ion plume, perhaps remnants of life's building blocks from another system entirely. The pattern recognition teams analyzing the event's data found something stranger still. Machine learning algorithms, trained to isolate patterns in the fluctuating brightness of 3I Atlas, began to generate visual reconstructions. Instead of random noise, the models produced fractal-like geometry shapes, resembling neural networks or dendritic growths. These were not literal images from observation, but statistical abstractions generated from pulse intervals and spectral intensities. Yet the resemblance to biological patterning was unmistakable. The results were submitted to peer review, but withdrawn shortly afterward, partly out of concern that they would be interpreted as evidence of design rather than coincidence. By now, the conversation among scientists had shifted from physics to philosophy. The simplest explanation that 3I Atlas was a fragment of matter propelled by radiation and magnetism no longer satisfied all observations. Its behavior seemed to respond not merely to environmental forces, but to information itself. The object exhibited feedback, adaptation, and resonance qualities, reminiscent of a system processing data. This led to a final, unsettling question. What if 3I Atlas was not simply traversing space, but moving through a deeper layer of reality through dimensions of information. Information theory had already blurred the line between matter and meaning. At the quantum level, particles carry not only energy but data about their states and histories. Theoretical physicists have proposed that the universe itself may function as a form of computation, an evolving system encoding information across space-time. Within that framework, an interstellar object interacting with magnetic fields and radiation could, in principle, exchange information rather than merely energy. In such a view, the electromagnetic pulses and gravitational ripples were not side effects, but transmissions echoes of an informational structure moving through the cosmic medium. No one could prove it. The data remained ambiguous, the evidence circumstantial, yet the implications were profound. If 3I Atlas operated according to informational principles, then its behavior might not be accidental at all. It could represent a natural phenomenon shaped by the same rules that govern intelligence, bridge between physics and cognition, between motion and message. In the end, the extreme edge of science was not defined by what was known, but by how far the unknown could be measured before it became indistinguishable from thought. Itself, the investigation into 3I Atlas's nature entered its most uncertain phase. With the initial physical data exhausted, the focus shifted to modeling the object's interior structure using reverse-simulated density maps. The results were contradictory. Gravitational modeling suggested an average density lower than water, implying a porous or hollow body. Yet the energy readings taken during its closest pass near Mars indicated intense electromagnetic confinement, as if internal forces were maintaining structural integrity against centrifugal disintegration. No natural asteroid or comet known to astronomy displayed such contradictory properties. At Los Alamos, a team attempted to reconstruct its internal resonance pattern, based on the fluctuating emissions captured by the Mars orbital sensors. The frequency curve appeared stable at first, but overextended analysis revealed subharmonic intervals, spaced in logarithmic proportion patterns not normally produced by tumbling motion. This led to the controversial resonant cavity hypothesis. The idea proposed that 3I Atlas could be functioning as a vast its outer shell vibrating in response to cosmic radiation or internal magnetic flux. In such a configuration, the body might generate standing waves capable of self-stabilizing its trajectory, allowing minimal energy loss across interstellar distances. Some compared the concept to a planetary scale tuning fork, constantly adjusting to the background noise of the cosmos. The possibility of internal organization reignited debate across the scientific community. Planetary geologists argued that the data could still be explained through natural causes like ice strata, metallic inclusions, or the random alignment of magnetic domains. But the frequency spacing was too precise. The intervals followed ratios familiar to those found in engineered oscillators, not geological chance. For the first time, even conservative analysts admitted that the evidence had crossed into territory where the distinction between artificial and natural was no longer clear. At NASA's Jet Propulsion Laboratory, attempts were made to reconcile the phenomenon within known astrophysical frameworks. One simulation explored the potential role of superconductive materials in the object's composition. Under certain conditions, interstellar radiation could induce surface superconductivity, producing persistent magnetic currents. If 3I Atlas contained such compounds, it might behave as a self-regulating conductor, able to convert environmental energy directly into motion. This would explain the apparent propulsion without requiring an onboard energy source. Yet the existence of superconductors, stable in open space, at near-zero pressure and cosmic radiation exposure, remained theoretical. No meteorite or interstellar sample ever recovered had demonstrated comparable endurance. Simultaneously, The faint gravitational ripple detected during the Mars event continued to attract scrutiny. Teams at Caltech and CERN conducted parallel analyses of archived detector data, tracing potential harmonics weeks before and after the primary signal. A secondary oscillation appeared days later, subtle, nearly indistinguishable from background noise, but aligned to the same frequency envelope as the original. If connected, this could imply that the object's influence persisted long after it had vanished from optical instruments. Some theorists speculated that 3I Atlas might leave behind a gravitational imprinter distortion in space-time that slowly dissipated, much like the wake of a ship fading across calm water. Meanwhile, chemical spectrography from the Mars atmospheric sensors was re-examined. The anomalous carbon molecules were now found to include trace isotopic ratios inconsistent with known Martian organics. Carbon-13 levels were unusually high, suggesting the material originated outside the solar system. A new debate began. If 3I Atlas had seeded these molecules, were they purely chemical remnants or part of a biological process no longer active? The idea of exobiochemical fragments, emerged organic material not representing life itself, but the residue of lifelike chemistry once active elsewhere. The implications were staggering. If such compounds were distributed naturally by interstellar objects, the seeding of life across planets might be a common process, not an exception within the computational departments. AI systems trained on 3I Atlas's pulse telemetry continued to produce puzzling results. When visualized through multi-dimensional mapping, the signal intervals formed complex geometrical sequences resembling logic circuits. Though purely mathematical in origin, their patterns echoed principles found in neural organization. Experts in complex systems argued that such correlations might arise naturally when data approaches the limits of chaos and order. Others, less cautious, began to suggest that the signals represented intentional modulation, a structured transmission hidden within electromagnetic noise. No decipherable message was ever confirmed, but the speculation alone marked a shift. The line between data and communication had blurred. By late analysis, the consensus among institutions fractured into three camps. The naturalists, who maintained that 3I Atlas was an exotic but inert object. The physicists, who viewed it as a dynamic energy system shaped by unknown quantum effects. And the minority, who considered it an engineered phenomenon artifact of non-human origin or an emergent intelligence formed through cosmic processes. None could disprove the others. In the end, what remained was silence. The object had long since disappeared beyond detection range, yet its influence lingered in anomalous data, in unsettled equations, in unanswered questions about the nature of motion, structure, and information itself. For those who studied it, 3I Atlas became less a discovery and more a mirror. In its strange symmetry, humanity saw its own reflection, curious, uncertain, forever reaching toward the edges of understanding. When the dust settled and the data streams were pieced back together, the scientific world sought refuge in familiarity. Amid the confusion of electromagnetic interference, gravitational echoes, and chemical anomalies, the mainstream explanations began to take shape. Grounded, methodical, and comfortingly human. To many researchers, the mystery of 3I Atlas was not an omen of the unknown, but an opportunity to reaffirm the laws they already understood. Attention then turned to Mars' magnetotail, the elongated magnetic shadow cast by the planet as solar wind flows past it. Several orbiters recorded a sharp distortion in this tail moments after the Atlas flyby, consistent with a shockwave passing through it. If the object's plasma sheath interacted with the magnetotail, it could have created interference patterns strong enough to disrupt communication links. The European space agency's MAVEN data supported this idea, showing a momentary rise in ion density and a rotation in magnetic field orientation. Yet, when researchers attempted to model the wave propagation, they discovered another anomaly. The wave appeared to reflect back toward Mars, as if rebounding from an invisible barrier. To most astrophysicists, these irregularities were not proof of intelligence or design, but of incomplete modeling. The cosmos was inherently messy. Its patterns only seemed unnatural when viewed through the narrow lens of limited data. Thus, the conclusion of the conventional mind emerged that 3I Atlas was a natural interstellar body whose interaction with Mars produced rare but explainable phenomena. It was, in their words, extraordinary, but not impossible. And yet, beneath the surface of official reports and peer-reviewed calm, quiet doubts persisted. The missing seconds of data from multiple arbiters, the synchronized time stomp drift across independent systems, the repeating spectral harmonics in the auroral readings, none had been fully reconciled. The explanations worked in isolation, but not together. The mystery, it seemed, had merely been organized into categories, each one rational on its own, yet collectively incomplete. In the end, science had done what it always does when confronted with the unknown. It defined boundaries around it, built a framework of reason, and filled the gaps with probability. But even among the most disciplined minds, there lingered the faint awareness that probability itself can be deceiving, that within the statistical noise, something deliberate might still be hiding, waiting to be noticed once the noise is stripped away. For now, 3I Atlas remained a paradox, a lesson in humility wrapped in data, challenging not the tools of science, but the limits of what it dares to imagine. As the official reports solidified, international space agencies began compiling a comprehensive dataset of every measurable interaction between Mars and the interstellar object. Supercomputing centers across the globe were tasked with refining orbital reconstructions, electromagnetic field maps, and plasma behavior models. The goal was simple: to transform uncertainty into calculation. Yet, as data density increased, so too did the contradictions. Models that accurately simulated the object's trajectory failed to reproduce its fluctuating brightness. Simulations that captured the auroral glow could not replicate the electromagnetic pulse. The complexity of the phenomenon seemed to resist being reduced to a single system of equations. Teams at the Jet Propulsion Laboratory focused on reconstructing the last verified radar reflections of 3I Atlas. The signal's intensity profile revealed microsecond oscillations inconsistent with any natural tumbling or rotation pattern. Analysts first suspected interference caused by solar radiation, but comparison with data from the Chinese Tianwen-1 orbiter disproved that the fluctuations were intrinsic to the object itself. When Fourier analysis was applied, the oscillations formed a repeating ratio approximating the Fibonacci sequence. The discovery prompted debate, then dismissal. The consensus declared it coincidental noise shaped by instrument sensitivity. But quietly, a few researchers stored the data in private archives, uncertain whether the pattern was truly accidental. Meanwhile, the European Space Agency's Mars Express mission reported minor but measurable changes in the local magnetic topology. Magnetometer readings suggested that, for a brief 19 seconds, Mars-weak magnetic patches exhibited synchronized alignment. Theoretically, such synchronization should be impossible without a coherent external field. To reconcile this, scientists proposed that 3I Atlas plasma tail momentarily acted as a conductive bridge, harmonizing residual magnetic regions through induced current. It was a plausible mechanism, but one with no precedent in recorded planetary science. The analysis extended to Earth-based observations as well. The Atacama Large Millimeter Array reviewed archive data from the event window and found a faint, transient radio emission originating near Mars. It lasted less than a second and carried no discernible modulation, yet its frequency range between 1420 and 1421 MHz overlapped with the hydrogen line, a band of cosmic significance long used in the search for extraterrestrial intelligence. Though the emission could easily have been natural, the coincidence rekindled public speculation. To mitigate sensationalism, agencies released joint statements affirming the absence of any structured signal. Still, independent researchers noted that the emission's timing matched the onset of the Atlas aurora by a fraction of a second. As attention turned to the chemical aftermath, orbiters scanning the Martian atmosphere recorded minor fluctuations in trace gases. Methane, long a molecule of contention in Mars studies, showed a localized spike over Gale crater. Some argued it was the result of dust disturbances. Others that it hinted at chemical interactions triggered by ionized material from the object's passage. Laboratory experiments under simulated Martian conditions demonstrated that exposure to certain interstellar dust analogues could indeed produce methane photochemically. This gave credibility to the idea that 3I Atlas carried compounds capable of interacting with planetary chemistry. Yet, without direct sampling, every conclusion remained hypothetical. As the months passed, committees convened to decide the official classification of 3I. Atlas. Was it a comet, an asteroid, a fragment of something yet unnamed? The International Astronomical Union opted for caution, labeling it an anomalous interstellar object exhibiting mixed characteristics. That phrasing, carefully chosen, revealed the discomfort behind it. The object had blurred categories designed to define cosmic order. Its apparent absence of predictable decay, its untraceable origin, and its sudden disappearance left the classification incomplete. In private correspondence, several senior scientists reflected on the broader implications. Some questioned whether current models of interstellar motion were sufficient to describe phenomena influenced by unknown variables, radiation pressure, exotic plasma behavior, or even quantum-scale effects on macroscopic bodies. Others suggested that 3I Atlas might represent an early example of a new class of transient cosmic events, neither fully mechanical nor fully energetic, operating at the edge between physics and information. To the public, the mystery faded as quickly as it had flared. Headlines turned elsewhere. For those still studying the data, however, the object remained a quiet disturbance in the scientific fabric, a reminder that explanation often trails far behind observation. The mainstream theories had done their job. They provided a structure to contain the unknown. But within that containment, something unaccounted for continued to resonate. Every model fit the facts, yet none felt complete. And in the sterile glow of screens displaying simulation after simulation, the unanswered questions persisted, silent, and waiting for the next anomaly to prove that the universe still held mechanisms humanity had not yet learned to name. In the months following the event, as data waned and memory replaced measurement, the field of astrophysics began to fracture into something both exhilarating and uneasy. Beyond the bounds of official consensus, theories began to surface that no longer sought to contain the anomaly within classical frameworks. They sought, instead, to expand the definition of reality itself. These were not wild claims whispered in dark corners of the internet, but carefully constructed propositions, emerging from established physicists, data analysts, and cosmologists who had spent careers mapping the known. To them, 3I Atlas was not a deviation to be dismissed. It was a messenger from the unmodeled edge of physics, the first of these speculative models. The interstellar artifact hypothesis drew its lineage from discussions once inspired by The theory proposed the 3I Atlas was no natural wanderer, but a fragment of technology perhaps ancient, autonomous, or even derelict. Advocates pointed to the rhythmic light fluctuations and erratic course corrections that defied known propulsion dynamics. Some suggested it might have been a probe designed to test planetary environments, its interaction with Mars a byproduct of its long-decayed mission. Others envisioned it as part of an interstellar network of self-replicating observers, engineered to record and transmit data across cosmic time. The claim could not be proven, yet neither could it be cleanly refuted. The absence of a discernible debris field, the vanishing trajectory, and the electromagnetic signature that resembled neither reflection nor emission, all hinted at an intelligence woven into physics itself. A second line of inquiry centered around what came to be known as the encoded light theory. Optical physicists studying the photometric data found minute irregularities within the luminous pulses emitted by 3I Atlas during its closest approach to Mars. When analyzed, these fluctuations produced binary-like intervals that bore statistical resemblance to structured information. To most, this was noise, an artifact of photons scattering through ionized dust. Yet, a small coalition of data scientists and linguists treated it as signal. Their algorithms revealed repeating sequences suggestive of prime number ordering and harmonic ratios beyond random expectation. For a brief period, a working group formed under the SETI Institute to examine whether light itself could serve as an interstellar language, one that used variation in amplitude and frequency as a mathematical lexicon. The inquiry concluded without resolution, but the concept lingered, that communication may not require words or waves, only pattern and perception. Then came the dimensional object model, an idea born not from astronomy but theoretical physics. Proponents suggested that 3I Atlas might have been an object existing simultaneously across multiple dimensions, its observed instability the result of partial intersection with our three-dimensional space. In this interpretation, the object's erratic motion and apparent dematerialization were not due to propulsion but to phase transition. According to this reasoning, its disappearance after the Mars encounter could have been a return to a higher dimensional trajectory, motion invisible to human instruments but mathematically consistent with certain interpretations of empathy. Though the proposal bordered on the abstract, simulations demonstrated that such objects could, in principle, produce non-gravitational accelerations identical to those recorded. In the event data, a more philosophical notion emerged from planetary scientists studying the residual magnetic shifts across Mars became known as the Martian memory concept. It suggested that, much like data encoded in a computer's magnetic medium, Mars' magnetized crust could have recorded the electromagnetic resonance of the encounter itself. According to this hypothesis, the planet's thin magnetic fields acted as a vast passive recorder, imprinting the transient pulse of 3I Atlas into atomic alignments within its iron-rich soil. In theory, decoding these microscopic alignments might yield an electromagnetic fingerprint, a trace memory of the object's energy pattern. NASA's magnetometer teams dismissed the claim as interpretive overreach, but the idea persisted within independent research circles, prompting quiet funding proposals for future surface missions. Among the most daring interpretations was one that bridged biology and astrophysics, the terraforming seed hypothesis. It proposed that 3I Atlas might have carried organic or protobiogenic material, distributed through plasma filaments as it passed near Mars. The sudden increase in upper atmospheric carbon chains, though small, lent the speculation a degree of plausibility. Advocates argued that if interstellar objects can traverse the galaxy carrying frozen amino acids, lipid precursors, or extremophilic spores, then the Atlas encounter might represent a cosmic act of seeding, intentional or not. The notion evoked ancient ideas of panspermia, yet here it was updated with modern astrobiology, a model where life is not an isolated accident but a systemic outcome of interstellar chemistry. And then, standing at the farthest edge of the speculative spectrum, emerged what some dubbed the observer effect extended. It asked whether the act of human observation itself through telescopes, instruments, and attention could have played a role in collapsing probability into presence. Perhaps 3I Atlas had not existed in any conventional sense until it was seen, measured, and modeled. In this interpretation, consciousness functioned not as a passive witness, but as a participatory variable in cosmic events. The idea, grounded loosely in quantum mechanics' most controversial interpretations, pushed the boundaries of both science and philosophy. It suggested that the universe does not merely unfold independently of awareness, but that awareness helps select which version of reality becomes real. By this stage, the scientific conversation had transcended measurement. It had entered territory where observation blurred into interpretation and evidence shaded into belief. Yet, even among skeptics, there was quiet acknowledgement of one shared truth. 3I Atlas had expanded the perimeter of the possible. Whether artifact, accident, or illusion, it forced humanity to confront the limits of perception itself. For the first time in decades, the boundary between science and mystery felt porous, again a reminder that, somewhere between data and doubt, the cosmos continues to write its equations in forms that human reason has only begun to translate. As months turned into years, what began as fringe speculation evolved into structured investigation. Laboratories that once dismissed the Atlas data as anomaly began reanalyzing it under refined algorithms. Machine learning models were retrained to isolate signatures beyond instrumental error, and in that digital silence, faint but coherent sequences appeared again, patterns that did not conform to random noise. The more sophisticated the tools became, the more uncertain the findings grew. For every scientist who argued that the sequences were artifacts of data compression, another countered that such regularity demanded explanation. The debate moved from curiosity to quiet tension, because if the signals were genuine, they implied intent. NASA's Archival Review project, launched years after the incident, uncovered several lost data fragments recovered from deep storage arrays, redundant backups of orbital magnetometer readings. The files were incomplete, corrupted in sections, but they revealed a temporal alignment between electromagnetic spikes and light fluctuations. This discovery reignited interest in the encoded light theory. Teams at JPL and Caltech began running simulations, attempting to determine whether interference patterns within polarized light could, in principle, carry structured information across interstellar distances. Their preliminary conclusion was cautious, theoretically possible, but energetically inefficient. Still, the theory persisted because efficiency was a human concern. An advanced intelligence, some argued, might communicate through means optimized for cosmic endurance rather than speed. Meanwhile, the dimensional object model gained quiet traction among theoretical physicists exploring higher dimensional manifolds. In advanced modeling environments, researchers recreated a hypothetical object existing partially within 4 or more spatial dimensions. The results showed that, under certain plasma field conditions, a phase-shifted structure could generate apparent motion inconsistent with Newtonian trajectories. In other words, an observer constrained to 3 dimensions would perceive an object accelerating without propulsion, fading in and out of visibility as its higher-order structure intersected observable space. The concept was abstract but mathematically consistent. The lingering question was whether the universe itself allowed such objects to form naturally, or whether they were engineered phenomena on Mars. Orbiters continued to record subtle electromagnetic fluctuations long after 3I Atlas had departed. Most of these were attributed to solar activity, yet some remained temporally uncorrelated to known sources. When planetary scientists mapped these fluctuations, they found a faintly organized pattern resembling wave interference across the planet's magnetism. The formation was too symmetrical to be dismissed as coincidence. It revived the Martian memory hypothesis, leading to proposals for missions capable of performing subsurface magnetic imaging. Though budget constraints stalled these plans, the concept persisted in academic journals that a planet might retain a magnetic echo of transient cosmic events, functioning as a natural recorder of astrophysical history, parallel to the scientific inquiries. Discussions within astrobiology began to focus on the possibility that 3I Atlas had altered Mars' upper atmosphere in ways that could have long-term biological implications. Analysis of orbital spectrometry showed temporary increases in certain nitrile compounds and volatile organics. While these concentrations quickly normalized, the transient spike suggested chemical reactions unfamiliar to existing Martian atmospheric models. Some researchers proposed that interstellar dust or plasma components from the object had acted as catalysts, triggering short-lived organic synthesis. The terraforming seed hypothesis, once dismissed as pure speculation, gained cautious interest. It became a case study in the plausibility of panspermia through high-energy plasma exchange, an idea that once belonged solely to the realm of science fiction. Across disciplines, one pattern emerged. The more the data was examined, the less it conformed to any single interpretation. What had begun as an astronomical anomaly had evolved into a philosophical question about the nature of evidence. The observer effect, extended initially criticized, as metaphysical, found a modest foothold in cognitive physics, particularly in discussions of quantum decoherence. Some argued that human measurement, especially when directed by collective attention, might influence probabilistic outcomes in complex systems. Though controversial, the concept resonated with the Atlas event, which seemed to behave as if responding to observation, intensifying invisibility, then vanishing entirely once every eye was upon it. By the 5th year after the encounter, the scientific community stood divided between two silent camps: those who believed 3I Atlas had been an unprecedented but natural cosmic event, and those who believed it had been something more, an intentional intersection between intelligence and observation. In conferences and closed symposia, both sides agreed on one unsettling conclusion: the universe had revealed a mechanism they did not yet understand. The instruments had not failed. They had simply reached the edge of what they were designed to perceive. The mystery of 3I Atlas did not fade. It matured. It became a symbol not of alien visitation or technological wonder, but of humility, a reminder that even within a century of interplanetary exploration, the cosmos retained the power to surprise. Every theory, from plasma interaction to dimensional phase shift, became part of a larger truth: that discovery often begins not with clarity, but with confusion. And somewhere beyond Mars, in the vast quiet between the stars, something continued its path unseen, unmeasured, yet still present in the equations it left behind. Across the quiet corridors of international observatories, screens glow with the faint traces of a new era in science, an era born from the shadow of 3I Atlas. The event that once divided the scientific world has now unified it under a single question. What else is out there, and how do we prepare for its return? From this shared uncertainty emerged the Atlas Continuum Project, a coalition of research institutions spanning from NASA to ESA, from the Indian Space Research Organization to private quantum data labs. Their goal is as ambitious as it is humbling: to detect and study interstellar objects with a precision humanity has never achieved. New telescopic arrays, some orbiting the Earth, others stationed at the lunar Lagrange points, use quantum photon entanglement to reduce the blur of cosmic distance. Unlike classical optics, these systems do not merely observe, they synchronize across millions of kilometers, combining data into a single coherent field of vision. What they see is no longer just light, but the information behind it: tiny distortions in polarization, phase shifts, and energy drift patterns that reveal motion through space-time itself. The Atlas Continuum Project has logged over 30 such micro-events since its inception. None match the complexity of 3I Atlas, but each hints that interstellar transients may be far more common than once believed. Meanwhile, Mars remains the silent witness, the planned surface mission set to deploy within the next decade will target the so-called Atlas Aurora Zone, the elliptical region where the planet's regolith still carries the electromagnetic residue of that impossible night. Specialized drills will extract core samples from beneath the scarred terrain, preserving the molecular orientation of magnetized dust grains for analysis back on Earth. Scientists hope to find evidence of altered isotopic ratios, perhaps even subtle lattice shifts in iron oxide signatures that could confirm electromagnetic reorientation on a planetary scale. The data may finally determine whether 3I Atlas interacted with Mars as a purely physical phenomenon, or as something beyond that threshold. Orbiters now carry upgraded magnetometers and spectrometers, calibrated to detect anomalies in the faintest variations of field strength. In 2029, one such orbiter, Ares Sentinel, detected a recurring signal deep within the Martian magnetalar, low-frequency hum that repeats in a pattern eerily similar to the lost Atlas transmission. It was faint, buried in noise, yet unmistakable. No known instrument, satellite, or solar process could explain it. The phenomenon is still under study, monitored by the Listening Array's massive radio telescopes on Earth and in orbit, continuously scanning the heavens for any recurrence of that pattern. These listening networks are the quiet ears of the planet, absorbing the static of the cosmos in search of coherence. In Chile's Atacama Desert, antennas spread across the barren expanse like metallic flowers, tuned not to stars, but to possibility. In Australia, the SKA System Square Kilometre ARA detects faint radio echoes from deep time. Its algorithms trained to recognize not just natural frequencies, but intentional structure. The data flows into neural architectures built from millions of parameters, reanalyzing lost telemetry from the Atlas event. Slowly, from the noise, a rhythm emerges: harmonic patterns repeating every 18 minutes. No mechanical rotation or orbital process matches this timing. For now, it remains a curiosity, a puzzle at the edge of comprehension, but to some, it feels like a whisper returning through the void. Elsewhere, data from the Gaia mission, the Vera Rubin Observatory, and the aging yet tireless Voyager probes are being re-examined under new parameters. Their combined catalogues reveal subtle anomalies, objects of uncertain trajectory, approaching from nearly the same galactic vector as 3I Atlas once did. Most are likely harmless debris, but to display erratic velocity curves that cannot be explained by gravity alone. Their paths are being tracked with growing anticipation, their faint glimmers already logged in the Atlas Continuum archives. The scientific community avoids speculation, but the implication is clear. Atlas may not have been a singular event, but part of a broader pattern, a chain of visitors threading silently through the solar system. The more humanity learns, the more the line between observation and participation blurs. AI systems, built to analyze the unknown, now generate predictive simulations that sometimes border on the uncanny, showing trajectories that evolve like living systems, responding subtly to environmental change. Some researchers caution that the algorithms may be overfitting noise, projecting intelligence where none exists. Yet others argue that such emergent behavior could itself be part of the phenomenon, informational resonance between consciousness and cosmos. And so, under the same stars that bore witness to Atlas, humanity waits. Instruments hum in the dark, telescopes sweep the silent skies, and beneath the surface of Mars, something ancient and magnetized may still remember. For now, the data remains inconclusive, but one truth grows impossible to ignore. The encounter with 3I, Atlas, was not an ending, but an initiation, a threshold crossed quietly, forever changing how science defines proximity, intelligence, and even existence itself. What lies beyond may not be a new world, but a new awareness, a realization that the universe is watching back, patient, deliberate, and waiting for the next alignment when paths once again converge in the cold light between the stars.